Hello everyone, welcome to lesson 10-3, Misleading Graphs and Statistics. Keep in mind that we are continuing to answer the question, how do you know which type of graph to use when displaying data? And as you can see, there is no new vocabulary for this lesson. Real world example. Hockey. The Stanley Cup is awarded annually to the champion team in the National Hockey League. The graph shows the total number of points scored at Stanley Cup playoff games by 3 players during their careers. So here are the 3 players. Okay? We have Gretzky, Messier, and Curry. According to the size of the players, right, you see that they're different sizes, how many times more points does Messier appear to have than Curry? Messier, you see, here's one line and here's the other line. It looks like he easily has double in Curry, right? But you can see that we start the graph at 180. So 180 is the very bottom. Then we jump up by intervals of 50, from 180 to 230, 230 to 280, 280 to 330, and 330 to 380. So we're jumping up by 50. So when you look at the graph, you would think the Messier has more than double than Curry, right? Because you see the side from here to here, and then it jumps. But this is a misleading graph because it looks like Curry has 230 and Messier has just slightly over 280. So let's just put him up maybe an even 300. So there's really only a 70-point difference. He does not double him. If you were to go by this chart, you would think that Curry has 230 and he would have at least 460, at least double, right? We see the misleading drawing. So Messi appears to have at least double. Question 2. Do you think this is representative of the player's number of points? Well, if we look at the graph again, we have to say that no, this is not a good representation because Messier looks like he has double the number of points, but in reality, he only has possibly at most another 70 points. So no, this is not a good representation of the player's points because again, it's misleading in the size. So, what reason could someone have for intentionally creating a misleading Stanley Cup graph? Well, the person who created the graph could be biased towards a specific team or player and might want to give them more credit than they deserve. My friend Lyndon says that maybe if people were using this graph that we see here to make bets on a team or make bets on a specific player scoring a playoff, they might show you this graph to mislead the betting, where they would think that Curry is only half as good as Messier and Messier is only half as good as Gretzky. They might not necessarily bet on these guys, but when in reality there's only 70 points difference here, and here we see only about an 80-point difference or so. So as you know, the main point to this lesson is how to identify a misleading graph. Graphs let readers analyze data easily, but are sometimes made to influence conclusions by misrepresenting the data. Here we have example 1 and we have 2 graphs, graph A and graph B. Spring dance tickets, spring dance tickets. On the side, okay, the vertical axis, we see the prices in dollars, and here we see the price in dollars. We see that they jump up by, they have intervals of $4, okay, 4, 8, 12, 16, and here we have intervals of $2, 2, 4, 6, 8, 10. So this one only goes up to 10, okay? The graphs show the same data. However, the graphs differ in that graph A uses intervals of 4 and graph B uses intervals of 2. Which graph appears to show a sharper increase in price? Graph B makes it appear that the prices increased more rapidly, even though the prices increase is the same. You see this? Just drastically because the intervals are by 2. So we see that we have a drastic jump from 2 to 8, which is a 100% change, right? Drastic. But over here it just says, no, it's only a little bit of an incline. It's not very much. But that's because these intervals are larger. Which graph might the student council use to show that while ticket prices have risen, the increase is not significant? And why? Well, I would think they would use graph A because they don't want people to think that the price has gone up by too much. They might use graph A. The scale used on the vertical axis of this graph makes the increase appear less significant. Okay, now let's practice. If you think you got it, go ahead and pause the video and try doing this on your own, or continue to play on. Pause now if you'd like to do it on your own. Okay, if you didn't pause, let's continue. The line graph shows monthly profits of a company from October to March. Okay, the profits a company makes from October to March. So that looks like it to be about 6 months. Which graph suggests that the business is extremely profitable? Is this a valid conclusion? Explain. Look at this one. Okay, we have, remember when we make these little lines here, we're saying that we're crunching a bunch of numbers in here, and then we start our interval jump. And that's because we don't want to start from 0 because our lowest number is 14,000.
It's time to go.
So now let's look at our increments. Okay, we have here, for example, as we mentioned, 14,000, right? And then it increases by 500, and then another 500, but then it breaks down into only hundreds. Notice that? It goes 14,000, 14,500, 15,000. It's jumping by 500s. And then it starts to jump only by hundreds, 100, 200, 300. Right? So it changes. The increments change. But over here, when we look on this side, we have 14,000, 14,500, 15,000, 15,500, 16,000. This one stays the same. The sequence, the increments, they continue to be the same. So the line graphs show monthly profits of a company from October to March. Which graph suggests that the business is extremely profitable? Is this a valid conclusion? So clearly, if we were to just not ignore this side and the increments, we would see this line and we would suddenly think, wow, look at how it's spiking. But really, when you look at it carefully, you notice that they started incrementing it with smaller or more. They put more increments in between, only by hundreds. So this is a misleading graph, and it is not a valid conclusion by any means. So what you really need to be careful of is make sure that you're matching the numbers. Here's 15,000 about 400, and which is the same here, 15,400. So make sure that you always read the vertical axis and the horizontal axis to match. Therefore, graph A suggests that the business is extremely profitable, but this is not a valid conclusion. The graph is biased or misleading. Our next part of the lesson is that statistics can be misleading. So statistics can also be used to influence conclusions. For example, an amusement park boasts that the average height of their roller coaster is 170 feet. Explain how this might be misleading. So the average, park roller coaster heights. Coaster, the Viper, is 109 feet. Monster, 135 feet. Red Zip, 115. Tornado, 365. Riptide, 126. So they'll boast that their average is 170, which makes everybody think, oh wow, they're around all the 170 mark, right? Or maybe 180, 165, around there. But really, when you look at the Viper, it's way lower, Monster is way lower, Red Zip is way lower, and the Riptide is way lower. The only one that is huge is the Tornado. So this one roller coaster is bringing the average up of all the other ones. But in reality, 4 out of the 5 roller coasters are much smaller than 170. And you know that to find the average, or what we call the mean, you add up all the numbers and divide by the number of numbers. So there's 1, 2, 3, 4, 5. You find the sum. So there's 5 of them. And after you find the sum, you divide it by the number of numbers and you get 170. The median is actually 126, the middle number. And there's no mode. No numbers are repeated. So in conclusion, the average used by the park was the mean. This measure is much greater than most of the heights listed because of the coaster that is 365 feet. So it is misleading to use this measure to attract visitors. A more appropriate measure to describe the data is the median, 126 feet, because a lot of them are around this height, which is closer to the height of most of the coasters. Now they could say this. They could say that most of the roller coasters are around 126, and they could really emphasize on how great this one is, and people might just come to the amusement park just to try the 365 feet roller coaster. Okay, let's try it now. Find the mean, median, and mode. Remember, mean is average, median is the middle number, and mode is the most repeated number of the sofa prices shown in the table. Which measurement might be misleading in describing the average cost of a sofa? Explain. So for example, sofa prices. We have a sofa, a leather one, 1,700, a reclining, 1,400, a do-it-yourself assembly, 350, a sectional, 1,600, and a microfiber, 1,400. So what they can do is to show that their prices are the lowest, or that their average price is much lower than these other prices, they could find the mean to all these. Now, how do we do that? Well, we add up all the numbers, 1,700, 1,400, 350, 1,600, 1,400, and then we divide it by the number of numbers. There's 5 of them, 1, 2, 3, 4, 5. And when we do that, we get 1,290. So if they really want it to be misleading, they could say in their ad that their average price for a sofa is 1,290, when in reality they're mostly around 1,700, 1,600, 1,400. They're lingering. Their prices, most of their prices are much greater than this price. To find the mode, right, we have to look at the numbers that repeat most, right? And the only one that repeats is 1,400. So our mode would be 1,400. So now in our medium is the number in the middle, and that's the number we put the number is in order from least to greatest, from greatest to least, right? However you want, and you just go right down to the middle number, and there's our middle number right there, right? So that would be 1,400. Now this would be a better price to talk about, because you have in the selections you have a couple of prices that are higher than this price, and you have a couple of prices that are either the same or lower than this price. So this one kind of sits in the middle, and this would be the best way to describe it. Some people might feel misled if you say your average price is this for the couches, but in reality 4 out of the 5 are higher than this. So this is a great example to see how advertisers could be misleading, or informations can be misleading. And finally, for this section, please take a look at our guided practice and read through it. Make sure that you feel comfortable with it. If you don't, go back to example 1, because this is a very similar activity to example 1. And you can see that question 2 is also related to example 1, question 3, example 2, and so on. Okay, boys and girls, we'll see you in class.